A 90-gram bullet moving at 300 meters per second strikes a 1.5 kilogram block. The bullet emerges from the block at a speed of 200 meters per second. How high will the block rise above its original position? Okay, so let's draw a picture. Here's going to be my block. Here's my bullet. This is going to be right when it hits. So let's say we know that it hits and it goes straight through. So let's say the bullet just comes out there. And then we have our second piece of this, which is the energy part. So we've done the momentum part, and then this is the energy part. And so our block is up here. There's still a hole in it that the bullet made, and there's still the bullet's still moving off. This is probably a long distance in between there. And so what we're trying to find is the height from here to here. So we're looking for this. If we say that this height is y equals 0, then this height is y final. And that's what we're looking to find. Okay, so let's do our givens. Our givens are the mass of the bullet is equal to 0.090 kilograms. The mass of the velocity of the bullet is equal to 300 meters per second. And the mass of the block is equal to 1.5 kilograms. Let's just remember to write this is my momentum. This is my energy. This is before and after. And for energy, this is before and after. But I think I wrote this kind of wrong. This was 300, or yeah, that's 300. And this is VB initial, meters per second. And then, so then VB final is equal to 200 meters per second. Okay, so the first thing we need to do is figure out the speed of the block. So we need to find the speed of the block here, right? So what's happening is the bullet hits, the bullet goes through, the bullet comes out the other end. So the block is going to be moving to the right, and so is the bullet going to be moving to the right. The motion of the block is limited by the tension in the rope. So that since the tension in the rope is there, it's going to rise to a certain height. Okay, so we're going to start first with momentum. So we're going to say we first need to find the V of the block final from the momentum equation. And then for part B, we need to know the Y final of the block, and we're going to do that from energy. So for A, we're going to start with P initial. Momentum initial is equal to momentum final. Right, looking at our before, we have our bullet is moving at 300 meters per second. So I'm going to have mass of the bullet, V of the bullet initial, plus mass of the block. V of the block initial is equal to both mass. And actually, yeah, it's going to equal both. So I'm going to have mass of the bullet times V of the bullet final plus mass of the block times V of the block final. And this is what we're looking for. We're going to assume, we're going to make a big assumption that there's no loss in energy with the bullet going through and making a hole in the block from bullet exiting. Okay, so for my initial information, I know the block is not moving. Set that equal to 0. I'm solving for this. So what I want to do here is I want to bring my this. I'm going to subtract this from both sides. So I'm going to have mass of the block velocity initial of the block minus mass of the block, sorry, mass of the bullet. I'm talking about the bullet here. Minus mass of the bullet, V of the bullet final, is equal to mass of the block, V of the block final. Okay, so I can group mass of the bullet times V of the block initial minus V of the block final. Sorry, bullet, I'm talking about bullet. Is equal to mass of the block, V of the block final. And now I'm going to divide both sides by mass of the block. So I get V of the bullet, V of the bullet final is equal to the mass of the block over mass of the bullet over mass of the block times V of the block initial minus V of the block, V of the bullet final. I should have used M1s and M2s. Okay, so plugging in V of the block final is equal to 0.090 kilograms over 1.5 kilograms. And this is going to be, this speed is 300 meters per second minus 200 meters per second. And when I solve this, I get V of the block final is equal to 6 meters per second. Okay, great. So now I'm only talking about when I'm talking about energy. The bullet went through. I don't care about the bullet anymore. And I'm just thinking about the block, right, going from here, here to here. So I'm going to use the conservation of energy. The conservation of energy says, so conservation of energy, that says K initial plus U initial is equal to K final plus U final. And so when we start, the block is going to be at 0. We look back at our figure, and when we finish, the block is going to be, it has no kinetic energy. It's going to have all potential. So here I can say 1/2 mv squared is equal to mgy final. You cancel out my m's. I know the velocity I'm going to be using here, right? This velocity is the velocity of the block. I'm just talking about the block, so I'll be using the 6 meters per second. Okay, so V then, I'm looking for Y, so Y final is equal to, I'm going to divide both sides by G. The Y final is equal to V squared over 2G. And when I plug in, so my Y final is equal to 6 meters per second squared over 2 times 9.8 meters per second squared. The Y final is equal to 1.8 meters. So that's the height of the block. We go back up here. The height that the block reaches based on the collision and the energy that it gained from the bullet hitting it, and then we see the rise in energy going from kinetic to potential energy.